Well, you can think of rational expressions they're kind of like a fraction, right? So how do we divide fractions? If you have a over b divided by c over d, you keep the a over b, you change it to multiplication, and then you do the reciprocal here. So it's d over c, and then it's a multiplication problem. So sometimes my students like to remember keep the first one, change to multiplication, and then flip. So they go keep, change, flip. Okay, so I'll show you how that's going to work in this example here. So they want us to divide the rational expression and express the quotient in simplest form. Okay, so I'm going to take care of the division right away. I'm not even going to factor first. So I've got 2x squared plus x minus 6 over x squared minus 1. That's the one I keep. Change the division to multiplication, and then I'm going to flip these. So it's going to be x squared plus 2x plus 1 in the numerator, and then x squared minus 4 in the denominator. Okay, so there's a lot of factoring here because you have 4 polynomials that you're trying to factor. So I'm going to start with the top one there. Now, you might want like a little scrap paper or something, someplace to factor 2x squared plus x minus 6. So if I do the grouping method, 2 times negative 6 is negative 12. So I want numbers that multiply to be negative 12 and add to be 1. That's going to be a 4 and a negative 3. So that means I have 2x squared plus 4x minus 3x minus 6. Remember, it's the middle that splits like that. You could put the negative 3x and then the 4x, that wouldn't matter. And then you draw the dotted line, you factor out the GCF of the first two, and then you're going to factor out a negative 3 in the back, and that changes it to plus 2 because you took out the negative. All right, the big thing is those parentheses have to be the same. They are. So I have 2x minus 3. Usually I put the x plus 2 first, don't I? Oh well. All right, and that's what I get. So that's going to be this one right here, that numerator, 2x minus 3 times x plus 2. You could always check that by multiplying it out. Now, what about this first denominator? That's the difference of squares, yay. So it's going to factor into x plus 1 and x minus 1 times, and now I need to factor this one. Well, that actually happens to be a perfect square trinomial, but if you didn't see that, you could write it out. The numbers are fairly small. You want to multiply to be 1 and add to be 2, and that's 1 and 1. So you get x plus 1 times x plus 1. Now, I talked about this in the other video. If you want, you can write it x plus 1 squared. I don't usually bother. I usually just write them out because it's easier to cross them out that way. Then you can see what you have, but that's up to you. And then the denominator, the other denominator, that's the difference of squares. So that's going to be x plus 2, x minus 2. Now, I'm not going to rewrite the whole thing. If you were to multiply, you'd multiply across. So you've got like 4 binomials in the numerator, 4 binomials in the denominator. Which ones get to go? Like you get to cancel. So I can cancel this x plus 1 with one of those x plus 1s. And I can cancel this x plus 2 with that x plus 2. And that's all I can do. So I just have to write the final answer. It's going to be 2x minus 3 times x plus 1 in the numerator. And then in the denominator, you're going to have x minus 1 and x minus 2. I wouldn't multiply them out. I would just leave it like that. All right.